In this video, we look at even more blueprints. By the end of the video, you can expect to have a launch pad which glows when you jump on it, a platform which can be raised and lowered using a button, and 3 different traps which all animate differently. If you're new to my channel and you're just dropping in on this video, I'm a game developer currently putting out Unreal Engine 4 and Blender content to help my viewers. If you have any tutorial requests, or you see anything on this list of topics that I'm covering that you're interested in, it would be so awesome if you dropped a sub. It really supports me putting out content. If you're just here for some quick knowledge on what I'm covering today, that's also cool. Regardless, I hope you enjoy the video. Welcome my friends to episode 8. Today's going to be an exciting day, so make sure you stay tuned till the very end. We're going to jump in and start this launchpad. So go onto Blueprints, right click, Blueprint class, actor, and call this launchpad. Then double click to open it up, add a static mesh which is the launchpad. Before we start working on the event graph of the launchpad, let's go into the materials emissive green, because we're actually going to create a parameter that we can change. So just bring in a constant here by pressing 1 and clicking, and then right click and convert this to parameter and call this brightness. Then plug this into the multiply and give it a default value of start at 10. Then click apply and go back onto your launchpad. But now we need to add a box collision for when we go over the box. We need an event to trigger, and just span this over the whole of the launchpad and then scale the Z down a bit. Okay, now we can start making this launchpad a bit more interactable. So go to the event graph. What we want to do is when the character overlaps the launchpad, we want to launch him in the air, and we can use a launch character node to do that. But first of all, let's bring in the event on component begin overlap. So when you overlap the box, then we want to launch character. But if you type in launch character here, you'll notice nothing comes up. This node can only be called in the character blueprint. So if you go into your content, third person, blueprints, and then you open up your character, here we can call launch character. But we don't really want to have to go into this third character to call it. So what we can do is go back into the launchpad, and then we can use the get actors of class to reference it and then call it from here. So we're going to get actors of class, we're going to get the third person character, or whatever your character is called. We're going to get a copy, and then we're going to launch the character here. So when we pull off this, we can actually get the launch character node instead of having to go into the blueprint. So throw in a value into your Z axis or whatever way you want to launch him, and let's go for a value of 500. So these little checkboxes here, this means it will override all his velocities. So if you do the X and Y, if you're running onto the launch pad, it will override it and it will take away all his speed, so then he'll just go up. If you change the Z, if he's jumping onto the platform, it will basically just cancel any velocity he has before applying this new velocity. So we're actually going to check both of these just to make it a bit smoother. If we run onto it now, you can see he just goes straight up. If you had those unchecked, you would just be running and you would be launched forward into the wall. But I'm pretty happy with it like this. So now what I want to do is actually get this green color to light up when we launch on it. To do that, go back onto your event graph, and on the event begin play, we're actually going to drag in the static mesh and create dynamic material instance. So what this node does, to put it simply, is it basically references the material that the static mesh is using. So the element index here, if we go back onto our static mesh, this mesh is built up of 3 material elements. We want to change the emissive green, so that's element 0. So just make sure your element index is 0. Then under source material, we want to change the emissive green again, so put emissive green under there. And then we're going to pull off here and promote this to variable and call this mesh material. Now we've got a variable and a reference to the material. We can actually change this as we please. So drag it in with control and drag, and then type in set scalar parameter value. So now if we put in the parameter name that we made in the emissive green, so that's brightness, Make sure you get it perfectly spelt with capitals and everything like that. We can then change the value of the brightness here. So if we just throw it to 100 for now, when we overlap it, the brightness should increase to 100. And there we go. So it lights up now, but it doesn't give us that glowy, flashy effect. So what we want to do is, like we've done in the past, is use a timeline. So we're going to right click, type in timeline, call this timeline whatever you want, double click to open it up, create a new float track and call this brightness. So what we want it to do is basically increase the brightness really rapidly and then decrease it really rapidly as the player jumps in it. So we're going to hold shift and click and create a value at time 0 and a value 10. We're starting at 10 because our emissive green brightness is starting at 10. So we don't want it to decrease in brightness then go up, we want it to be at the brightness it already is. So then we're going to shift click again, and this value is going to be at 0.4 and this value is going to be 100. Actually we'll go for 0.5. Then we're going to shift click again and put the value of time 1, value 10 to go back to our start brightness. Then just change the length to 1 second or however long you did it for. So now go back onto your event graph, plug the brightness into the value here, plug this into the play from start, and then plug the update into the scalar value, and that should be it. So let's just go back to the start and see how this works. When we're when we play the level, we're creating a reference to the material of the static mesh, the emissive green. Then we're turning that into a variable. Then when we overlap the box, we're get actors of class to launch the character in the air, which it can only be called in the third person blueprint, or if you reference it and call it off the get. Then, after we've launched the character, we're creating a timeline to increase the brightness up to a value of 100 over 0.5 seconds. Then at 1 second we're decreasing it back to 0. So now if we play this, and there we go, it increases and then decreases. You can shorten the time it takes to get to that value because it looks like it's still a little bit delayed. But for now I'm just going to leave it. You guys can tweak it as you feel necessary. So let's move on. The next thing we're going to do is do our rising platform with a button. So we're going to duplicate the button and call this button lift. We're then going to duplicate our moving door up because it uses similar nodes. So duplicate this and call this platform rise. Platform ris. And first we're going to go into the viewport and just delete the things that we don't want. So delete the decal, delete the box, and then delete the top static mesh. And then we're just going to rotate this 90 degrees and maybe thin it out a tiny bit. Okay, so we've got our platform. Cool. You'll notice that when we click compile now, we've got this bad error and there's an error icon up here. That is because we've deleted our static mesh node, which we were using as a reference. So we just need to delete this, which was trying to get its location. So now if you compile, it will work. Okay, so this blueprint's pretty much doing everything we want so far. We want the Z location of the static mesh to increase over time. As we've deleted the reference point we were using, we're going to have to manually put this in. So put this to 250. Then delete the on begin overlap because we no longer want to overlap and it to rise. We want it to rise when we call it. So make a custom event, call this go up. Now we're going to make another custom event called go down, and then we're going to duplicate all of this. So then for the go down, we're actually going to swap the Z axis around. So we're going from 250 to 0 instead of 0 to 250. So now it will go up and down. So if we go onto our button, button lift, don't need this. And then we need a reference to our platform ris. So I'm going to type in platform ris or whatever you call it. Change variable type. We're going to change the name. Then delete the open doors, and then when we overlap the button, we want it to go up. So we're going to type in go up. And then when we get off the button, we actually want it to go back down. So then we're going to pull off this and say go down. This is still called door moving split for some reason. Yeah, I thought so. So we're going to bring in the platform and just do it like this. So when we go onto the button, the platform will rise from 0 to 250. Then when we go off it, it will go from 250 to 0. So now if we test this out, when we go on the platform, it goes from 0 to 250 over 3 seconds because of the timeline. And when we go off it, it goes from 250 back down to 0. But you'll notice that if you stand on it and then go off it, it teleports. And the reason it teleports is because when we're telling the platform to go up, we're telling it to go from location 000 to 00250. What if the platform isn't at 000? That means, so if the platform's at Z location 50, and then we run this, it's going to teleport back to 0 and then go up to 250. Same with the going down, we're telling it to go from 250 to 0. What if it's at 100? It's going to teleport up to 250, then go down. So what we need to do is change this value so it's the platform's current location. So we can do this with a variable. So if we bring in our static mesh, then say get relative location. We use relative because we're setting the relative location, not the world. Then if we promote this to a variable, call this current location. So when this go up is now run, we're getting the static mesh's location, and then we're playing this. And then instead of using this set location, we're going to use its current location. So regardless of where the mesh is, we're going to find out where the mesh is, and then from that location, we're then going to go to 250. So then we need to do the same for the going down. So just select this all, then Control W, and then bring in the current location at the top here. So now regardless of where it is, it will go down from that point instead of going down from that set value of 250. So you'd think we'd be done here, but there's one more thing we need to do. Because these timelines change a value over the course of a set number of time, in our situation we've got it going over 3 seconds. Once they've started, they won't stop unless you've told them to stop. So if we tell the platform to go up and then the platform starts running, what if we then tell it to go down and try and do this new timeline? This timeline's going to keep on playing and still going to try and move it up, even though we've now told the platform to start going down. So what we need to do is actually to stop the other timeline from running. So we use a sequence for this. A sequence is basically a node which will run one thing, then run the next, then run the next, then you can keep on adding more and more pins as you so please. So we're going to play the timeline, and then we're going to use the other pin to stop the other timeline. Then we need to do the same for the top. We're going to play the timeline and stop the other timeline from running. So if we play this now, the platform will move up when we stand on it, and when we get off it, regardless of the platform's position, it will move up without any teleporting. So now we're going to make 3 trap blueprints. The first one we're going to make is a spinning shuriken. So you already know how to do this from the coin, but we're just going to quickly do it now. So blueprint class, actor, Shuriken, so I think it's Shuriken. Then double click to open it up, add a static mesh. By the way, you can always name these components, but most of the time I don't do it just because I'm lazy. And then bring in the Shuriken, it is with an E. Then we're going to do exactly like we did last time. We're going to bring in the Shuriken with control and drag. We're going to add a local rotation. Then we're going to make rotator. Then we're going to +1 to the Z. And then we're going to plug the event tick onto that. So this is going to fire a constant stream of local rotations, and that's at point, and we're adding 1 each time. Let's actually add this up to 3, just so we can get a super fast spinning shuriken. And then let's scale it down. These traps are all going to be in miniature form because we don't have a lot of space. But if we play this now, there it goes. Okay, trap 1 done already. Let's move on to trap 2. The next trap we're going to make is a swinging mace. So right click, blueprint class, actor, and then call this, I'm just going to call it trap 2. Then bring in the static mesh. Can't remember what I called it. Here we go, spike mace. So what we want it to do is rotate from the ceiling like that. But as the origin point is not at the top, if we try and rotate it, it's going to rotate like this. So like we've done before, what we need to do is add a scene component. So now if we move this scene component up to the very top, then we attach the mace to the scene component. Now we can rotate this scene component and it will rotate from the top like so. So now we just need to rotate the scene component over time using a timeline. So let's go into our event graph, make a custom event called swing. Then bring in our scene component. Then we're going to set relative rotation. Then we're going to lerp to go from one rotation to another one. We're going to click shortest path and then go back onto your viewport, and we'll do it in the Y. So we'll put a rotation of -40 in the Y. This is a bit awkward. Then to +40. So what shortest path does is basically makes it so it rotates from -40 to 40 in the least distance possible. I won't go into detail explaining it because I actually can't. It's quite a difficult thing to explain. But if your rotation is going all over the place, it's because shortest path isn't ticked. It's trying to get from negative to 40 a different way around the 360 clock instead of going 80 degrees, 040 to 0 to 40. A bit hard to explain, but over time you'll understand it better. So this is going to go from -40 to 40, but what we want it to do is actually go over time. So again, we bring in a timeline. Call it whatever you want again, and add a float track. You can call this whatever you want. I'm going to call it swing. Then we're going to shift click to have a value, have this at value 0, 0. Then we're going to shift click again and put this at 1.5 and a value of 1. Then shift click again at 3 seconds. We're going to go back down to, not 9, to 0. Then we're going to change the length to 3 seconds. Then we're going to compile, then go back into the event graph. So put the swing into the alpha, put the update into the set relative location, then put the swing into play from start. So you may be getting a bit confused that for the trap, for the launch pad, we actually plugged the value straight into the value slot, and for our trap, we're plugging it into the alpha. So basically the timeline just creates a value and you can change that value over time. So in this case, we're changing the value to 100 because we want the value brightness to be 100. But in our trap, we're using it for the alpha. And you need to remember that the alpha is like a percentage. At 0%, it's at this value. At 100%, we're at this value. So we only need to go up to 1, which translates to 100%. So we're going from 0% -40 to 100% 40, and then back down to 0%. And that's what this triangle is. That's all well and good so far. It's going to swing, then come back. But it's only going to do that once, and we want it to do it a few times. So we're actually going to drag off finished and type swing, so then it repeats this. And we actually need to start it. So we've got this event, but we're not calling it, we're not telling it to begin swinging. So on event begin play, we're going to bring in the swing. And now we should see that when we get our trap in, our hammer should be swinging. And there we go. So you'll notice it looks a little bit robotic at the moment. So let me show you one thing we can do with timelines to actually make it a bit more smooth. So if you jump back into your timeline, you'll see these are our values, and you'll see they're going very linear, straight to one value, then straight back to the other one. But if you select them all, then right click on the points, we can actually change how they transition into one another. So if we change it to auto, we can now curve up to that value, slow down a bit, then curve back to the other value. So if we play this again, you can see it's got now more of a swinging motion. So that's another trap down. Let's move on to the final trap. The final trap we're going to do is a spike core, which fires in and then slowly moves back. So instead of having to redo all the nodes, redo all the timelines, we're actually going to duplicate trap 2, then call this trap 3. Double click to open this up. Now we're just going to rename this event just so we don't get confused. We're just going to call this smash. We're no longer changing the rotation, so we can delete that. We no longer need a scene, so you can delete that. You can delete the lerp, and you can leave that how it is. So now go into the viewport, detach the static mesh from the scene, delete the scene, and then bring in the wall spike wall. Put the rotation back to 0, and then set the location to 0. So we're just resetting all the transforms. So now we want it to move out like this. So we want it to plus 500 to the X axis, and then we want it to go back to 0. So back onto the event graph, bring in the static mesh, set relative location. You should be slowly getting the hang of this now. Then we want it to lerp, so we want it to go from one location to another. Then we want it to go from 0 to 500. Then we want to bring in the alpha from our timeline, plug that in, and that's actually everything we need to get it to go out and then come back. But if we do it like this, it's just going to bounce back and forth. It's not going to look like it's slamming. So we need to go into the timeline, and then we can actually change all these back to linear. So select them all, right click, change it to linear, and then we want it to slam really quickly and then slowly pull back. So if we put this at a time at 0.5, might be a bit quick. Then if we make another value, put this at 0.8, then a value of 1, then it will slam, pause for like 0.2 of a second, then slowly go back, and then because we're calling the event again when we finished, it will rinse and repeat. We're actually going to add a delay in here, so press D and hold D and click to bring in a delay. Change this to 0.4, and now this trap should be looking pretty smooth. Pauses for a second, slams in. We could even get it slamming quicker, but this is just a very rough version. You guys can change it how you want. But as far as it goes, these traps are all finished now. Just need to make them a bit bigger, get a different spike trap because this one looks a little bit naff, and then you're good to go. So guys, that is everything for today. I hope you enjoyed the video. Please do let me know if I'm going too quick. Let me know if I'm explaining things well enough, because I want to pass on my knowledge as well as I can to you guys while going as quick as possible, but I don't want to go too quick that you don't understand and then we actually end up going slower. So we've got a nice set of blueprints here. The reason I went so into blueprints was because blueprints are the essential part of Unreal Engine. When you get those right, you can really start doing a load of things. So we're going to work on some health bars and mana bars tomorrow, so that's going to be really cool, and the game is really going to start to shape up. So thank you for watching, and I'll see you in the next episode.